Did you know what scaffold and tissue engineering is? First, scaffold. Scaffold is a structure of artificial or natural material on which tissue is grown to mimic a biological process outside the body or to replace a diseased or damaged tissue inside the body. A scaffold can provide structural support for cell attachment and subsequent tissue development. Then, tissue engineering is an interdisciplinary field that aims the development of biological substitute, the restore, maintain, or improve tissue function. The use of cells that placed on tissue scaffold in the formation of new possible tissue for clinical purpose. However, it is no longer restricted to purpose involving cell and tissue scaffold only. For your information, ceramic scaffold play a crucial role in the field of tissue engineering. Ceramic scaffold offering a promising approach for the regeneration and repair of damaged or a diseased tissue.
The problem occurs when ACL injury. The first one is pain and swelling. ACL injuries offer cause immediate pain and swelling. The severity of pain can vary, but it is generally a significant concern. The second problem is instability. The ACL plays a crucial role in stabilizing the knee when it's injured. Individuals may experience a sense of instability, a feeling that the knee is giving way or cannot support the body's weight properly. The third problem is limited range of motion. Swelling when associated with an ACL injury can lead to reduced range of motion. It may be challenging to full strengthen or bend the knees, affecting the mobility. The fourth problem is functional impairment. ACL injuries can impact an individual's ability to participate in activities that can require climbing, cutting, or sudden change in direction. This can be particularly limiting for athletes and those with active lifestyle. The fifth problem is muscle weakness after ACL injury. There is often muscle weakness in the quadricep and hamstring muscle. Strengthening this muscle through rehabilitation is crucial for restoring stability and function. The sixth problem is risk of secondary injury. ACL injury can increase the risk of developing secondary injuries such as meniscus tears or damage to other ligaments in the knee.
I'm going to explain problem solution for ACL injury, which is anterior glute ligament injuries, by ceramic scaffold in tissue engineering. Using ceramic scaffold in tissue engineering to address ACL injuries involves several steps. First and foremost, scaffold design. Create a ceramic scaffold that mimics the structure and mechanical properties of the ACL. The scaffold should be porous to facilitate cell infiltration and tissue regeneration. Nextly, biocompatibility and integration. Ensure the scaffold material is biocompatible and capable of integrating with surrounding tissues without causing adverse reaction. Furthermore, cell seeding and growth. Seed the scaffold with appropriate cells such as fibroblast or stem cells capable of differentiating into ligament cells. Cultivate these cells within the scaffold to encourage tissue growth. Moreover, mechanical strength and support. Engineer the scaffold to provide initial mechanical support to the injured area, assisting in stabilizing the knee joint during the healing process. Following that, gradual degradation. Design the scaffold to degrade gradually as the new tissue forms, allowing the regenerated ACL tissue to replace the scaffold over time. Last but not least, in vitro testing and evaluation. Conduct rigorous testing in animal models to assess the scaffold's effectiveness in promoting ACL regeneration, ensuring its safety and efficiency before human trials.
Ceramic scaffolds in tissue engineering act like supportive frameworks or structures that help the body rebuild damaged or lost tissues. Let's imagine them as scaffold used in construction, like for our body tissues. For the first one, bone repair. Ceramic scaffolds help in fixing broken bones by providing a sturdy structure for new bone cells to grow and replace damaged areas. For the tooth restorations, for dental tissues, ceramic scaffolds support the rebuilding of damaged teeth by giving a structure for dental tissues like dentin and enamel to grow. For the cartilage healing, injuries to the soft tissues like cartilage can be aided by ceramic scaffolds, since it offers a framework for the repair and regrowth of healthy cartilage. For joint implants, to get an artificial joint like a hip or knee replacement, ceramic scaffolds are used to help the body integrate the new joint smoothly with natural bones. And for the drug delivery, these scaffolds are used as carriers for medicines. They slowly release drug in a controlled manner, influencing how cells respond and aiding in the healing process. For the blood vessel creations, in cases where blood vessels are needed, ceramic scaffolds assist in building artificial blood vessels, supporting the growth of cells that form the vessel wall. And for the injuries to the anterior cruciate ligament ACL in the knee, ceramic scaffolds can potentially be used to help the body regenerate a functional ACLs. In conclusion, ceramic scaffolds are like friendly guide for the body's repair crew, providing a solid structure and environment for new cells to grow and replace damaged or missing tissues.
Now I'm going to explain about properties of ceramic scaffold. I have listed down 10 properties of ceramic scaffold. The first is biocompatibility. Ceramic scaffolds are often biocompatible, meaning they are well tolerated by living tissues. Second, porosity. Ceramic scaffolds exhibit controlled porosity, providing a three-dimensional structure that supports cell infiltration and nutrient diffusion. Third is mechanical strength. Ceramic offers good chemical strength, providing structure support for tissue regeneration. Fourth is osteoconductivity. Ceramic scaffolds promote bone growth by serving as a scaffold for new bone formation. They are osteoconductive, facilitating the integration of new tissue. Fifth is biodegradability. Some ceramic scaffolds are designed to be biodegradable, gradually breaking down over time as new tissue replaces the scaffold. Sixth is thermal stability. Ceramic often exhibit high thermal stability, ensuring that the scaffold maintains its structure and properties in psychological conditions. Is chemically inertness. Ceramic are generally chemically inert, minimizing the risk of adverse reaction with surrounding tissues. 8 is tailorable pore size. The pore size of ceramic scaffold can be tailored to mimic the natural extracellular matrix, influencing cell behavior and tissue regeneration. 9th is surface modification. The surface of ceramic scaffold can be modified to enhance cell adhesion, proliferation, and differentiation. Radio opacity. Some ceramic material used in scaffold possesses radio opacity, allowing for easy monitoring and assessment using medical imaging techniques. That's all for me.
I want to discuss about the advantage of ceramic scaffold. First, I want to talk about many ceramic scaffolds have osteoconductive properties, meaning they provide a supportive environment for the formation and growth of new bone tissues. Second point is, most ceramic scaffolds have a composition and structure similar to natural bone, so this will increase compatibility with the host tissues and facilitate the natural regeneration process. Thirdly is, ceramic material enable medical monitoring of scaffolding progress and tissue regeneration using X-ray. And lastly is, some ceramic material have intrinsic antibacterial properties, which can be beneficial preventing infection during the healing process. That's all. Thank you.
In conclusion, the utilization of ceramic scaffold in tissue engineering holds immense promise and potential for revolutionizing the field of regenerative